plasma cosmology and the electric universe can inspire, in my opinion, a scientific revolution of unparalleled scope. We see on the left there a planetary nebula and a plasma discharge tube, just as an example of the similarities. And they hinge on one simple question, in both cases, plasma cosmology and the electric universe: does electricity play a role in the universe? The electric universe cosmology, a guiding principle of this is convergence of all human knowledge. This is why I've been associated with David Talbot and the comparative mythologists, because that extends our knowledge right back into prehistory. And when you think about the short time that we've been observing the skies with modern instruments, it's a very narrow view of the history of the skies. We do not want merely a modern consensus in one single specialised field. What is plasma? Moving plasma generates electric currents and forms current sheets, filaments and bubbles. It produces radiation over large parts of the electromagnetic spectrum, and this makes radio astronomy extremely important in the future. There's already sufficient information to be able to overturn, in my opinion, all of the nonsense about the Big Bang available from radio astronomical observations. Interestingly, plasma behaviour is extremely complex, far more than I ever imagined. As I say here, the flow of electricity through plasma can cause glows, arcs, jets, filaments, beads, bubbles, kinks, sausages, tornadoes and explosions. That's a pretty fair range of phenomena to be going on with a single mechanism. It's just as we see in the lab, and as it turns out, it's just as we see in deep space. Of course, this has been mentioned, the electric force is 10 to the 39 or 10 to the 40 times stronger than gravity. And one of the scientists who was involved with the Velikovsky story early in the piece, Dr. Earl Milton, wrote an article called "The Gravitational Force is Zero," and he used this little example at the bottom. Gravitational force divided by the electric force is 10 to the minus 39, which is as good as zero as you can get. So we cannot ignore the electric force in the universe. In a plasma universe, we have to ask what physics lies behind these wonderfully mysterious objects that shine in deep space. All these glorious photographs we get from space are being viewed and interpreted by people who have no experience in plasma physics. It's obvious that energy has been supplied to the thin gas in space so that some atoms become ionised and glow. Astronomers are restricted to explosions to deliver the energy to this ionised gas. And in some cases, the distance between the glowing envelope and the central object that's supposed to have exploded precludes the explosion being responsible for the energy that we see radiated by these spectacular planetary nebulae. So the plasma universe can be far more complex than we ever imagined, while the underlying principles are very simple. And this makes it amenable to examining concepts and matching them with observations. Plasma cosmology is the study of the electrical behaviour of matter on all scales. That's from the atomic up to the galactic cluster. It's based on sound empirical principles and laboratory comparisons. It accepts a universe of unknown extent and age, which is the kind of thing which Halton Arp's work, I think, is suggested is the case. And it forms the backdrop of the electric universe. On the left you see electrical discharges across the room of the Sandia Z machine, as they call it, which produces the most intensely concentrated electric discharge on the planet, man-made discharge. And it says for billionths of a second it focuses about 80 times the entire world's output of electricity into a few cubic centimetres. And in that instant we see the sorts of patterns which we see in deep space, and we see chiselled in rocks on the surrounding country, out in the surrounding countryside near Los Alamos. Christian Birkeland is one of the electric universe pioneers. He was a Nobel Prize nominee and a pioneer. He built a model electromagnetic Earth, his Torella experiment, to mimic an aurora. And a good book about his life is by Lucy Jago called The Northern Lights. It's a good read. The thing is that this Torella needs electric power to work. So the phenomena we see in his experiments has to be powered electrically externally, and this is important, of course. He wrote, "It seems to be a natural consequence of our points of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds." He was rather prescient in his statements. There's more to come. These filamentary currents, which follow the magnetic field, the ambient magnetic field, which you can see here, are named after him, and it is the force-free means of transferring electrical power from one part of the universe to the other. The current filaments naturally form double helix or twisted pairs at every scale, from the laboratory to galaxies. And that's due in part to the difference in mass of the positively charged particles that carry the current and the negative, of course, the electrons that carry the current. It's interesting how these small differences here and there account for the complexity. So in deep space we have cosmic power lines. The electrical power transmission lines in space are usually in dark discharge mode. In other words, they can't be seen, however they can be traced by radio astronomers. That's why I say radio astronomy is extremely important. Birkeland currents are to be found on all scales, from the lab to the galactic cluster, and can be detected by their magnetic fields. So like birds on a power line, we're unaware of the energy coursing past us so far. This is an experiment I did in Melbourne at the laboratories of the major telecommunications carrier with high voltage equipment. That red insulation is wrapped around a very heavy gauge copper pipe, and it's connected via this rod, which I'll show you in action in a moment. It's going to close the circuit between those two conducting balls you can see there. And this is the result. It's compressed in both radially and longitudinally. It came down very hot. I had to toss it around until it cooled. And here we see an example in space of the very same effect. We're looking down the barrel there of a planetary nebula. This is an example of the electromagnetic pinch. It's also called the Bennett pinch. And you'll see here three examples. One, the laboratory example, the Southern Crab Nebula in the centre, and supernova 1987A, which is one of my favourite objects, since it shows all of the phenomena we would expect from a plasma pinch effect in space, and suggests that supernovae have nothing to do with an internally generated explosion in a star. Alfvén had an article published in the Boston Globe, I think it was in the 60s, and it was under the heading of Alfvén's Electric Universe. But one of the important statements he made was important fields of research, for example, the treatment of the state in interstellar regions, including the formation of stars, are still based on a neglect of Bennett's discovery, that's the pinch effect, more than half a century ago. Present-day students in astrophysics hear nothing about it. He said that in 1986. Starbirth. One of the features of an intense lightning bolt is that the current can actually pinch off totally so that it forms bright beads or plasmoids. So bead lightning appears with a particularly powerful fork lightning. It looks like the lightning discharge channel has broken up into a string of glowing plasma beads. So last year there was a report from the Herschel Space Telescope, which is looking in infrared into the birthplaces of stars. And here's a quote from the paper. A view of an incredible network of filamentary structures and features indicating a chain of near-simultaneous star formation events glittering like strings of pearls deep in our galaxy. That is, in effect, bead lightning in an interstellar cloud. There was a subsequent paper which examined some of these filaments in more detail, and here's the quotes from that paper. The filaments are huge, stretching for tens of light years, and regardless of the length or density of a filament, the width is always roughly the same. That's like cloud-to-cloud lightning. But the explanation of the astronomers is that all of these kinks in that are caused by exploding stars. So I asked the question, where are these exploding stars? And shouldn't there be some sort of radial curvature associated with those filaments? Instead of that, it has the same kind of tortured path of lightning. and the stars form along those filaments. An important aspect of the formation of stars and of all condensed bodies in the universe is this effect that occurs in a Birkeland current filament, and that is that it scavenges very efficiently widely scattered material and draws it into the central axis of the Birkeland current filament. Now the interesting thing is that in the standard model of the collapse of the protostar material, it's all radial, and astronomers have cooked up a story whereby the final collapse of all that material is adiabatic. In other words, there's no heat escape. Because the material here is distributed along that filament, the coolest part of the matter here is along the axis. And the other very important aspect of Markland convection is that all of the cool, low ionization potential elements, which you can see there are carbon, sulfur, iron, silicon and magnesium, all the things you need to make up a planetary core, are deposited along that filament at the axis. Of course, once you've got sufficient material along that axis, there is a tendency for it to break up into blobs or into stars. So this means that they must constitute the core matter of stars, not hydrogen. You'll notice that hydrogen and helium are on the outer rim of that Birkeland filament. So this destroys any idea that stars have hydrogen cores. Another thing that Hans Alfvén said was, by analogy with the magnetospheric circuit, we may expect the heliospheric circuit, that's the one of the Sun, to have double layers. Now, double layers are a situation where a current is flowing through a plasma and the plasma encounters a sufficient change in the density or the temperature or whatever, the plasmas on either side, it will form a double layer. A double layer has positive charge on one side, negative on the other, and it creates radio noise, it accelerates particles to cosmic ray energies, it can, and they are situated on the axis of these currents. Okay, so he said no one has yet tried to predict how far from the Sun they should be located. So far, no one has cared to look for such objects. That was in 1986. So here's a prediction way back in the 80s. This is a picture of his circuit. Over here we have the yellow Sun, and here are the polar axis currents, and you notice the double layers up here and down here, symmetrically situated along the rotational axis. The circuit obviously has to be closed, so somehow out here you get this flow this way. This is looking at the electron flow in this particular case, because obviously protons flow from the Sun in the opposite direction along here. We know that. Hans Alfvén took the traditional view that the Sun is a thermonuclear bomb going off slowly, and therefore that it was the source of the current, and he called it a homopolar generator. We take the different view that the Sun is being powered externally, and that this circuit is actually connected to the interstellar circuit. It's induced by the current that's flowing past the Sun. So what do we find? This is a very recent report. They found local cosmic rays, and they can find no source for them. And they're situated in the polar regions, north and south. This is a picture of the ice cube neutrino detectors buried at the South Pole. And they were surprised to find these hotspots, they call them, 0.03 light years away from Earth, because they must be within that distance actually, because further out galactic magnetic fields should deflect the particles and smear them across the sky. So here we have evidence for another of Alfvén's predictions. Of course, no such sources are known to exist conventionally.